Hey, hello there. Welcome back to Karotul. My name is Arpit Pandit, and let's get on the bus. So, today we are going to talk about bus topology. So, wait a minute, what do we mean by topology? So, basically, what happens in networking, of course, you don't want to connect just two computers. Like I mentioned in the first video, you can connect it with the cable. Yes, you can do that, but in your organization, you might have more than two computers. You want to connect them. So, how do you connect more than two computers? That's where you need to think about a topology. So topology is a diagram logic which you will use, which by which means you are going to connect your multiple devices, right? So the very first thing they did initially when the networking is started and they had to connect more than two computers, they used a simple bus topology. Now, what is bus topology? So let's talk about it. So bus topology is simply that using a single cable, which is called a single segment, as you can see. And this cable connects to multiple different computers using a little bit thinner cable. That's why you will see that these cables used to call thick cable, which is the main backbone cable, and then thin cable, which used to extend to the PCs, right? And remember, this is just a cable, so it doesn't understand any packets, frames, or any computer networking technologies. All it understands is electrical signals. So when a computer sends some traffic, it sees electrical signals are coming in, and it spreads the electrical signal everywhere else. And that's why we have to put the terminators both side. Otherwise, the signal will bounce back. So we need to absorb the signal and stop it right there, right? So if you see that from the computer to the main bus, it's creating a inverted T sign, right? That's why they used to be called T connectors, which you use to connect this thick cable to this thin cable, right? So what is the thick and thin cable we are talking about? So the cable that they use in bus topology was the coaxial cable. Coaxial cable was actually a copper cable, which is braided inside a plastic sheet, and then and it is secured by a rubber or a plastic black casing, as you can see, right? But there were two sizes, thick size and thin size. So the thick one was the main backbone cable, and then you extend the connections to the computers using the thin cable, as you can see into the diagram, right? Now, the connectors that we use in this were called bayonet Neal concealment connectors, or BNC connectors. And as you can see, I already mentioned that there were terminators on the both side, but then you have the T connectors, PNC T connector, which creates a T inverted T sign to connect the PC to the main bus. And then there were BNC plugs into the computer network interface card. So you have the network interface card. Remember the mouth and the ear for the PC? Those network interface cards used to have the BNC interface. And we can see that the cable which extends to the PCs is called the thin coaxial cable, and the main piece, the backbone cable, is called the thick coaxial cable, right? Now, if we see the actual images, you will see that the numbers here, number one and number two. So the number one is basically your terminators, which absorb the signals and do not let them bounce back. And then number two is your BNC T connector. So that's how they used to look, the T connectors, to extend the connection to the computers or to any other devices, right? And this is the example of a coaxial cable where you have the copper wire inside an insulation, and then you have a copper mesh so that you cut any kind of electromagnetic interference, and then the outside insulation, which is generally the plastic outer black color cover, right? That's what it looks like. So, what are the benefits or the issues with this particular topology? So, if you use a bus topology, you will see it's simple to install, cheaper as no networking devices are needed, and less cable is needed compared to some other topologies you will see in future videos. The problems were the biggest enemy in bus topology is the broadcast, which means sending to one but going to all. Similarly, like if you want to say something to a person who is inside a party, maybe standing other side of the room, and if you shout something to him, of course it is for him, but everyone else will also listen. Similarly, similar thing happens into networking, which is called broadcast. Broadcast means one to all, because the bus topology just sees the electrical signals coming in and it spreads them everywhere. So what can happen is that first of all, there is security issue because you are sending it to one but everyone is listening. Second problem happens, which is a bigger problem, is the collision. Collision means when you have an accident between two different data streams, because these are two different electrical signals coming to the bus at the same time. and of course the bus is trying to spread both signals and they collide, right? And because of this, you will see the network becomes slower, and sometimes the data is completely lost. Difficult to expand also. Limited scalability is there. It's not very easy to install these cables patches if you have a very long distance. And of course, signal also starts to wear down. Also, if there is a fault in the cable anywhere, it will take the whole network down. Why? Because remember, there were terminators on both sides to absorb the electrical signals. But if there is a cut in the cable somewhere, the signals will bounce back from that point, and of course, it will collide with other signals and make the complete network useless. So you can see that's the basic idea behind the bus topology. Thanks a lot. I'll see you into the next one.